So this is chapter 4. We're going to start talking about loops, more specifically the while loop. Alright, here's a quick overview of everything we're going to be going over. We're going to talk about what loops are. We're going to revisit increment and decrement operators. We're going to talk about the while loop, hit up the do while loop, talk about infinite loops, talk about the break and continue operations, and talk about two new Unity functions we're going to introduce, the random.range for random number generation. And we're going to talk about time.delta time so we can get accurate readings on how much time has passed from frame to frame within Unity. And we're going to see what we can do with all these new tools and concepts by going over how we can make an asteroid field inside of Unity. Alright, so loops are real easy to talk about. It's just a sequence of instructions repeated over and over and over and over until a condition has been met, kind of like how conditions are met in if statements. Let's quickly review increment operators. This is going to be very important in loops, and you'll see why in a second. Remember the plus plus. Here's some quick examples. If you do a plus plus to any kind of integer, it'll add 1 to it. So that'll be useful when we start talking about counters inside of while loops. And also the minus minus is the opposite of the plus plus, and it subtracts. So let's look at while loops real quick. The best way to explain while loops is to start using some basic examples of how they operate. It's kind of like an if statement in that we have a while right here followed by a parentheses in which you will input a conditional check, like is 3 less than 1, is 1 equal to or greater than -8, things of that nature. The difference between an if and a while is the code inside the body of a while statement is continually repeated until this condition is met. So it's useful if we need to do multiple things over and over again. That's when we would use a loop. So let's look at some examples inside of Unity. I have a fresh new scene started up here. I have an examples script ready to go. And let's just add a new game object so I can attach this empty script to. We'll call this examples. And I'm just going to click and drag my example script onto here. And let's double click on our C# script called examples. And let's open up MonoDevelop. Alright, I've already tidied up some code in here. And mainly loops are going to exist within your update function inside of MonoDevelop. Since loops continually repeat, then it wouldn't make much sense to have them in the start function, since they run more than one time. Remember, start functions run only once whenever the game starts and no more. Void update is where we're going to be living for most of the time. There are exceptions to the rule, but let's just focus on the void update. So let's go ahead and get the syntax down for what while loops can do for us. Alright, so let's just start with a basic while loop. And most loops are going to make use of what we call a counter variable. So I'm going to go ahead and declare a counter variable for future use. We'll call it a public int, and let's just call it counter for right now. So to do a while loop, we'll start with saying while, and there we have our parentheses. And while, let's see, what can we say? Let's take our counter and say while counter is less than 10, and let's put our brackets. Again, the auto format in Unity, I'm just going to hit Control-Z to undo that format. So anything within this code is going to be executed until the end of time, or until this condition is no longer true. So we can say something like, for right now, let's say do a debug.log. And let's say the counter is now, and then we can do a plus, and then we'll just print the counter variable right here. And this will give us an idea of what the counter is doing inside of Unity. But you got to remember though, this whole while statement is dependent on counter being less than 10. Right now, without a declaration or without an assignment, counter is 0. So right now, this while loop is an infinite loop. It will always keep going, which is bad inside of Unity. So to combat that, we're going to use an incremental operator that I showed you earlier. So we'll just do ++ counter, end it with a semicolon, and we'll hit Control S, and that's our first while loop right here. And let's go to the engine and see what we get. Let's bring up my console. I'm going to bring it up a little bit so we can see all the messages we get in my panel here, console window. I'll hit play. And now you can see I have a series of debug.log messages. If we go to MonoDevelop, we can see that the debug.log message says the counter is now, and then it prints the counter. Notice how the counter starts at 0, and every time we go through the loop, we'll write this comment right here and print the value of the counter variable, and then we'll add 1 to the counter variable, and you can see what that does inside of Unity right here. It adds all the way up to 9. So we'll go through this loop around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times, and then through the 11th time going through, counter now equals 11, and since 11 is not greater than 10, the loop terminates and we get no more statements being printed here. Notice how how it stops before it gets to 10. Well, that's because 10 is not greater than 10, so the while loop again terminates. Pretty simple stuff. Let's make it a little bit more complicated, okay? And let's add an if statement within our while loop. All right, and I'm going to change it up a little bit more, and we're going to do a public bool, and we're going to have a flag variable. Flags are commonly referred to as yes or no's. They're perfect for booleans. Basically, when we flag this variable, we'll flag it yes or we'll flag it false. And let's modify our code a little bit more. Let's say while flag, and why don't we go ahead and give flag an assignment as true, not tour, but true. So right now, as the code reads, while will always equal true. See this right here? So let's just see what happens inside of Unity now that we have a while statement that always equals true. I'll clear this up. I'll hit the play button. All right, waiting for the game to load. Wait a minute. I can't click on anything. MonoDevelop's still up. This is an infinite loop. And we'll talk about what that means in a second. But basically, anytime this happens to you while you're working with while loops or any kind of loop, Unity will freeze up. You won't be able to do anything except kill the program hardcore. If you're on a Windows machine, you can hold Control-Shift-Escape, and you can bring up the task manager. And notice how the Unity process on here says not responding. That's a dead giveaway that an infinite loop has wrecked our program. Notice how we don't get any syntax errors, and we compile the code straight out of the gate. Unity will not give you any error messages if you have a while loop. It's only a logic error. So I'm going to have to kill Unity real quick. So let me end this task. I'll pause the video and I'll bring Unity back. 1 second. Okay, so I got Unity back. Right now, our first order of business is to make sure this infinite loop is squashed. We need to take care of it. So right now in our while loop, we need to figure out a way to turn flag false so we can get out of this while loop and everything be, it doesn't crash Unity. So what kind of code can we add here that would stop that? Well, I'm going to make a few changes real quick to my counter variable. In the world of loops, instead of calling the variable counter, we just simply use lowercase I. And this now means I is universally recognized as a counter variable inside of your loops. So there we have I, and we can see that counter is no longer used, so it's in kind of pink letter. I'll change that to I right there. All right, so let's add a few lines of code now. Let's put an if statement in here. Let's say within our loop, if I is less than 10, or if I is greater than 10, rather, well, what are we going to do? Why don't we set flag to false? And let's give a message now. And let's say the counter is greater than 10. So we have an if statement that checks for this. Alright. We turn flag to false, which ends the loop. Alright, great. So what is this code going to do? Basically, remember, let's just walk through it step by step. As soon as we hit play, this while loop is going to start going, and since flag is declared assigned as true up here, the while loop is going to start running. It's going to read the counter is now I. I'm actually going to put that below the if statement right there. So with that changed, every time we go through our loop, the first thing the loop's going to do is going to increment our counter variable right there. All right, plus plus I. Then the loop's going to run this if statement. It's going to say, all right, is I greater than 10? And since our first time through the loop, 1, I is now 1. So is 1 greater than 10? No. So this code is skipped, and we display this message. So go through it a few more times. And let's say I is now incremented to 10. So is 10 greater than 10? No. Again, the code is skipped. We print the message. Now that the counter is now 10. And we go all the way back up to the while loop. Now I is plus plus I means we have 11. Is 11 greater than 10? Yes. So now we run this code. Flag is set to false. We get this debug.log message. And we skip this message right here. So we don't get to see what the value of counter is as soon as it turns 11. Let's hit Control S and save. And hopefully our infinite loop is squashed. Let's bring up my console and let's see what the code says. Alright. So what does our code tell us right here? Well, we have our while loop going through, and it displays 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once I hits 10, we go through the while loop again. 10 equals 11. 11 is greater than 10. Flag is now set to false. We get this message right here. And we still are going through our while loop. I think a second ago, I think it says we skipped this message, but we haven't gotten to breaks yet. We'll get in that next. This message is displayed, and we see now why the loop is terminated, because the counter is now 11. So if statements can be used inside of while loops to help your while loop avoid infinite statements and to do other types of other types of instructions, other types of checks. It'll be useful whenever we start going over our assignment in a second. All right, so those are a few uses of the while loop right there. We have an example right here. That's basically what I just showed. We're not really going to go over do while loops. I just want to let you know that they exist. The syntax is a little different. You start with a do, and then you have the brackets, and you do the code in the body. And then at the end of your brackets, you have the while conditional check. The only thing I want you to bring away from the do while loop is do while loops will run code at least once. It'll do this code here the very first time it goes through, the first time you press play, and then it'll do your conditional check. All right? We're not really going to use them, but they exist. I want you to know what they might be if you see it. Here we have our infinite loops. Remember what we had earlier? Our while loop was just always true because we never had that if statement to turn the flag to false. It's a loop that never ends. It'll crash Unity. And remember, there was no syntax or console errors there to let us know we had an infinite loop. So we got to be real careful about those. Here's some examples. Basically, this is what crashed our code earlier. Instead of just a true, we had a boolean that was true with no if statements turning it to false. I mentioned breaks earlier. Let's see how breaks work. Basically, anytime there's a break inside of a while loop, any code after the break will be skipped. All right, so let's see an example of that real quick. Let's say that I didn't want to print the counter is now 11. I just wanted to skip this debug.log. Well, all I have to do is type in break right here. Notice how it's a little different color. It's the same color as our while loop right here. Basically, that means anytime there's a break, the while loop terminates no matter what. Any other code inside of this while loop is skipped. Let's hit Control S, and now we should see that there is no counter is now 11 debug.log message. Let's clear it out. Let's hit play, and there we have it. We skip our debug.log because we typed in break there. So the only thing we did there was whenever your counter variable, hit 11, we still flagged the flag variable as false. We still printed out the reason why, and then we just added that break there, and we get out of the loop immediately. There's also a continue function here, or continue operator. It's the exact opposite of while, in that it still skips any code below, but it goes up to the top of the while statement instead of ending it. So let's see that in action. Alright. That's all we got to do here. Let's take out our break right there. Let's add another if statement. If I is equal to 5, then we'll just type continue here. Alright, so from what I told you about continue, in that anytime this condition is met or anytime a continue is executed, it skips all the code below it, but rather than break out of the while loop completely, it just goes to the top and keeps running. So if I equals 5, so if the counter equals to 5, and we hit this continue, what do you think it'll display? Well, let's find out. I'm going to go hit Control S to save my code here. We'll hit play. Let's clean that up a little bit, see what it does again. So let's go through our messages real quick. We have our while loop going through once, twice, 3 times, 4 times, 5. Wait, notice how my counter skips from 4 to 6. Exactly. Remember, the continue skips any code below, recycles through. We still have our counter being incremented. And since we have that continue outside of this check right here, we don't get the message that the counter is now equal to 5. Alright. So here's an example of our continue here, if you need to go back and double check. So let's talk about a few new functions in Unity that will help us with our asteroid field before we really get into it. Alright. Random.range is going to be our easiest way to access number generator functions inside of Unity. It creates random floats between a minimum and maximum value. So you have random.range, and then in parentheses, you'll have a minimum float and a maximum float. So if we go down to our example right here, we have a public int, random number, and we have our random range here. That means that any number in between -10 and 10 will be chosen at random, and random number will be assigned that random number. Alright, so let's see this in action real quick. Let's get rid of our while loop and let's just focus on randoms. Alright, so let's make a new public float and call this random number. We'll get rid of that flag variable. So let's do the syntax here. We're going to do an assignment in the update function. Random number is going to be equal to capital random dot range. Don't forget your parentheses. And then we set the minimum value, which will be 10.0f, to make sure Unity knows we're talking about floats. And then we do a comma there, and then we do 10.0f. Hit the semicolon. We'll hit Control S to save. Let's clear out our console. And now we see that our example script is updated with the public random number variable here. If we hit play, let's see what happens. Notice how we're just getting an assortment of random numbers constantly cycling through, because in our update, every frame we're setting random number to a new value in between -10 and 10. That's going to be useful whenever we start spawning asteroids to fly towards our ship. We'll want the asteroids to spawn anywhere along this y-axis on our game screen here. We want it to be able to spawn up here, down here, in the middle, and everywhere in between. So let's go ahead and download the assets for this chapter. And when you do that, come back to the video and I'll start walking us through our assignment. Okay, so we've downloaded our assets for this chapter and we've imported the package. Import package, custom package, and then you'll choose the chapter 04 assets and you'll get this file structure, folder structure set up. I have a few things here. I have an asteroid prefab that you can see here, and I have the spaceship prefab that you can see here. So first things first, let's go over a new method in which we can quickly get player movement working inside the Unity engine using physics. Really basic stuff. There's going to only be a few steps involved here. So why don't we go ahead and drag and drop our prefab into our hierarchy. You can see my ships right here. Just so we can get some light in, let's go to Game Component, Light, and let's add a directional light. Just get it out of the way. We're going to want to reposition some things in our scene here, so let's go to our scene view. Let's rotate our ship 90 degrees, and you can pinpoint that in your transform component up here in the inspector. I'll type 90 in the inspector. And why don't I bring my camera a little bit back so I have a bigger playing field on which to move my character. So once you get your scene set up, we're going to create a new script. Okay. Let's call this, we're going to go to our scripts folder. We're going to right click in the empty space. We'll go to create C# script. Let's call this player mover. We'll double click it to bring up mono-develop. And now you can see I have a brand new script. Let's get some formatting going just the way I like it. And let's start typing out some code. Last time we declared a public float speed so that we can describe in the inspector here how fast we want our player to go. We're not going to need our void start, but we are going to need something a little bit different here. We're going to use a fixed update function instead of just update. That's because since we're using physics, we're going to change this to fixed. Unity can get kind of weird with physics and just a regular update. It all has to do with how frames are calculated. A fixed update gives it a more reliable way to calculate physics that's not based on exact frames per second, but rather a fixed rate of frames per second. Because if your frame rate's going all over the place and you're doing math calculations based on distance over time, it's not a very clear, accurate portrayal of true physics if your frame rate stutters. So the fixed update gets us around that. So in the fixed update, we're going to do a few new things. We're going to describe a new float. Let's call this move horizontal. And we're going to go ahead and assign it a value. And we're going to do a input.get axis. And we're going to call this horizontal. Let's do one for move vertical. Basically what we're doing here is a varied method of the input.getKeyDown. It's just another way that Unity can do key inputs. Basically, when it reads get axis horizontal, it knows to read the A and D buttons on your keyboard. And if it does the vertical, it knows how to read the W and S buttons. So just type that word for word. And then we're going to have a new vector3 variable. Remember, vector3 is the variable we use for our transforms right here. So we'll call vector3, and let's call this movement. So we're basically declaring variable movement of type vector3, and this is going to equal to a new vector3 based on move horizontal for the x plane. Remember, vector3s always have x, y, and z values. We're going to have move vertical for the y axis, up and down. And then we're just going to have a 0.0f value for the z axis, which is the depth axis, which is in and out, or far and near. Since we're not going to be moving closer to the camera, and this is a 2D game for all intents and purposes, we don't have to solve for the value of z. There's no depth in this game. And then we got to do something a little weird here. We're going to add a new component to our medium fighter. So we'll select our medium fighter. We'll go to add component. We'll go to physics. And we'll add a rigid body. This is a component inside of Unity that allows you to affect physics on an object. We're going to unclick gravity because in space there's no hard gravity here. And now we can mess with its velocity, its mass, its drag, all kinds of things like that. So with our medium fighter now having a rigid body physics component on it with gravity turned off, we can now start assigning forces to our ship based on what keys we press using the get axis functions there. So we can go rigid body dot velocity. Remember, velocity is a way to describe movement in the physics world. And we'll do movement, which we described here. So every frame we're going to get a new value for movement based on how we press our keyboard. Movement times speed as a multiplier so we can get the moving. We'll hit Control S. And these 4 lines of code, 5 if you count declaring the public variable speed, will give us player movement. And in my opinion, it's a lot smoother than directly updating the values of our translate values that we did last time. Alright, we'll hit Control S. We'll hit play. Our ship's not moving at all. We must have messed up. Nope, we just haven't assigned the variable player mover to our prefab. So that surely will get it, right? We'll hit play. I can't move again. What's going on? Well, that's because on our player mover, our speed is set at 0. So basically we have no speed. So let's set that value to 5. Hit play. And now we have a new method of moving. And you'll notice that whenever you release your buttons, your ship kind of has a little bit of physics to it. A little bit of momentum being conserved. It doesn't automatically stop. So it's a little bit more fluid way to drive your ship. Alright, now that we got that taken care of, let's start setting up our asteroid field. So the first thing we're going to have to do is we're going to have to make a prefab of an asteroid that moves, much like the bullet in the last chapter, as soon as it's instantiated. So let's go to our prefabs. I have the asteroid here for you. Let's drag it into my hierarchy, and you can see it in my game window right here. And I already have a script set up for us called mover. Click and drag the mover script right onto asteroid A. We have 2 variables here. We have a lifetime, which describes how many seconds the asteroid will exist. I have it default set to 10. And object speed. Right now I have it set to 0. Why don't we set it equal to 6? And we can press play. and we can see my asteroid moving to the left. It's not a very believable looking asteroid since it's not rotating, but we're going to keep it simple in this lecture, and we're just going to worry about positions, and let's not worry too much about rotation at this point. Alright, since our asteroid A is updated and has a new mover script on it, I'm going to delete the old prefab asteroid A. You'll notice that asteroid A in my hierarchy turns pink. That means the prefab that used to describe it is no longer there. So to remedy that, we'll just click and drag asteroid A into our prefabs folder. Asteroid A is blue again, and now our asteroid A prefab has a mover script attached to it. And I'm going to get rid of it in my hierarchy real quickly. Alright, the next thing we're going to do is we're going to create a new empty game object. Let's reset its values over in the transform panel. Let's call this Game Manager. Game Manager objects in Unity usually hold things such as stats for scores, or in this case, a spawning system for our asteroids. It's just an empty game object that we can attach scripts onto. So let's go to our scripts folder down here in Assets. Let me make this a little bit bigger. We'll select Scripts, and we're going to right click our empty space again, go to Create, C# Script, and let's call this Spawner. Alright, let's click and drag Spawner onto our Game Manager. And now our Game Manager game object has a new script attached called Spawner. And this is where all the magic is going to happen for this lesson. Alright, so bear with me. We're going to keep going through this assignment. I'm going to double click on Spawner. I have a new script here. I'm going to go ahead and get rid of Player Mover. I'm going to do a little bit of tidying up. There we go. So just follow me step by step and I'll explain myself as we go. First, we're going to start out by declaring some public variables. We're going to go public float. And remember how I was using the random number generator and talking about the randomization on the y-axis so we can get our asteroids to spawn in places other than directly the middle? Well, we're going to have a min y variable. And we're going to have a max y variable. Then we're going to have a public float again. And let's call this random y. Alright. Just a little bit better formatting. We'll hit Control S. This variable here is going to allow us to set the minimum y range. This variable is going to set the maximum y range so we can describe the range in which we want our asteroids to spawn. Random y is going to hold our random variable, our random position for our asteroid is going to spawn. Alright, so we saw how random numbers work, so let's put them to work for us. Alright. So let's go to our void update, and let's set random y equal to random range, and instead of directly saying -10 or -6, we're going to just type in min y and max y. Let's go ahead and hit Control S and see what our code's doing for us right now. I'll select my game manager. We can see my new public variables pop up, and what we should see, well, nothing's being updated. We're not getting those random numbers. That's because we have to set our minimum y and our maximum y values. Alright, so how are we going to know what values to put here? Well, let's do a little trick, and this is helpful. Sometimes your game window will be right beside your scene. Well, it's going to be helpful to be able to see both of these windows right here. So I'm just going to click Game and dock it right next here, or you can drag it out as its own complete new window. But I like to dock mine right beside Scene. I'm just going to grab my ship real quick, and I'm going to move it up. And it looks like 11 will be the top value here. and -8 will be the minimum value here. And I just did that by moving my ship object in the scene view and seeing just how the values lined up on my game window. So we have 11 maximum and looks like -8 for our minimum. I'll go ahead and reset the value there. Let's get my game manager. My minimum Y was -8. My max Y was 11. We hit play. There we have my random Y number, just picking a bunch of different values in between these two guys right here. Alright, so now we have a guaranteed method of getting random Y values, so we can start using a while loop to start spawning asteroids for us. Alright, so let's keep going with the code. Alright, so now we're going to need a few more variables. We're going to create a public vector3 variable, and let's call this spawn position. This variable here, let's go ahead and Control S, and I'll show you what that variable gives us. Here we have our vector3 variable, and notice how it's an X, Y, and Z values here. Our spawn position is going to directly tell us where we're going to spawn our asteroid when we instantiate it. Alright, let's have another variable, and let's do a public float and call this position X. Hit the semicolon. Well, what is position X for? Well, we have random numbers to give us the value of the up and down area in which the asteroid spawned. But right now, as it stands, we don't have any values for where on the horizontal plane or axis our asteroids will spawn. So right now they'll just spawn right on top of our player out of nowhere, and it won't look very good. So let's assign our position X value a variable of value. And we're going to do the same thing. We're just going to drag my player until he's out of the screen. So it looks like my asteroids are coming from off screen, but really they're just being instantiated just beyond what's rendered in my game scene. So that looks like 14. Why don't we just round that up to 15? And now we'll have a value on the X plane for our spawn position. Alright, let's keep going with our code here. So before we get into our while loop, let's just go ahead and see how we can instantiate an asteroid into our scene. Alright, we'll go to instantiate. What are we going to instantiate? Well, remember last time we instantiated our bullet by using a GameObject variable. So I guess we need one more public GameObject variable, and we'll call this Asteroid. Let's go ahead and get rid of that instantiate real quick. We'll hit Control S. Now I'll see in my game manager I have an asteroid. I think I misspelled that. Oh well, we'll just keep going with it. And I'll go grab my prefabs, and we'll drag and drop asteroid A right onto this new public GameObject variable. And now my spawner knows that anytime I want to spawn an asteroid, it'll point to this prefab right here. So let's go ahead and bring back my instantiate function, and we're going to instantiate asteroid. Where at? Well, we know we have a variable called spawn position, but we've only declared spawn position. We haven't assigned it any values yet. So let's do that real quickly right here. Let's say spawn position is going to be equal to a new vector3, and within this vector3 we're going to say position X and my random Y, and again we're going to ignore our Z axis, and there we go. This line of code right here takes my spawn position variable Remember, it's that vector3 variable with the 3 x, y, and z values here. It's going to do a new vector3 value with position x for the x-axis, my random y on the y-axis, and 0.0f because this is a 2D game. We don't need that third axis. So now that I've instantiated my asteroid, I've said, okay, I want to instantiate this prefab. Now I need to describe the position, which is just spawn position. And now we need to describe a rotation. Since we're not going to be working with the rotation, we're going to use the quaternion. Don't worry what those are right now. Just type in exactly what I'm doing. Quaternion identity will just match the rotation of our game manager object to the rotation of our asteroid. We'll go over rotations further down the chapter. For right now, just believe me that quaternions are the values we'll use for rotations, much like vector 3s are the values we use for position. So position, vector 3, rotation, quaternions. Just a little heads up for you. All right, we'll hit Control S, and let's just see what my code does real quickly. All right, we don't have any syntax errors. Everything's looking good. Let's hit play. Holy moly. I don't think you'll be navigating through this asteroid field. So we know we have random locations from asteroid being spawned. They're not just spawning in the middle. We have a whole range, as we can see in my scene view right here. See how they're just randomly spawning outside of my game view here at different Y locations? Oh, so many. Right now what we have to do is we have to dictate how many asteroids get spawned. We don't want just an infinite mess of asteroids coming at us. That's where our while loop will come in handy. So let's see how we can use a while loop with the code we just did to control how many asteroids are going to spawn on us. Let's bring back my code here. Well, the first thing I'm going to want to do is go to my update, and let's go ahead and just type a while statement. While what, though? Well, I know that we talked about counters a second ago in my while loops, so I'll know I'll need a counter. And I'll probably want a way to say how many asteroids I want to spawn. So why don't we go ahead and make two new variables for both my counter and the number of asteroids I want to spawn. Let's go public int and call that I for my counter on my while loop. Let's go to public int for, let's see, what should we call this? How about asteroid count? How many asteroids I want to spawn. Alright, I'll hit Control S. So let's say while my counter is less than asteroid count, we're going to do some code. Hit Control Z to undo that formatting. So we've already got this nice code here that finds a random value for the y-axis, sets the position, and then instantiates the asteroid. I'm going to do a little bit of tidying up. Why don't I just highlight that code? I'll hit Control X or go to Edit and Cut. And inside my while loop, I'll just hit Control V or paste. And now we can get my code inside of this while loop. The syntax looks good. Everything's going great. And why don't I go ahead and, yeah, let's just hit save and see what happens. I'll hit play. And my asteroids aren't spawning. What am I doing wrong here? Huh. Alright, well maybe I need to, oh, my asteroid count's at 0. No wonder. Okay, I'll set my asteroid count to 10. Oh no. What happened? I just set another infinite loop. because I have no line of code in here that increments my counter to 1. So right now as it reads, I is always going to be less than asteroid count, and I've crashed Unity. So don't make that mistake. What we're going to want to do is we're going to want to do, and there goes Unity stopping working. I'll go ahead and close that. I'm going to want to increment my counter. So every time we go through the loop's going to check if the counter is less than the number of asteroids I want to spawn. If that's true, it'll find a new random number every time I go through the loop. It'll set a new spawn position every time I go through the loop. And it'll instantiate an asteroid at the spawn position that I have described with that quaternion identity showing up the rotation value here. And then after it spawns my asteroid, then it's going to increment my counter so that my while loop won't crash Unity anymore. So I'm going to hit Control. I'm going to pause this and bring my Unity back. Oh no, and I've made a fatal mistake. I didn't save my scene. So my infinite while loop just made me waste so much time here. Hopefully you weren't following along too closely and did the same mistake I did, getting your infinite loop to crash your thing. But you know what? I'm going to rebuild everything because I'm new to this, and setting up scenes gives me as much practice as I can handle, I guess. I know, I'm sneaky and probably don't like me too much right now. So I'm going to pause this and I'm going to reset up my scene. If you need tips on how to redo it, you can rewind the video. I'll be right back. Alright, so I'll just go through it again real quick. My medium fighter, I'll rotate it at 90 degrees. I don't need it. Make my empty game object and call this Game Manager. I'll make sure it's not nested under medium fighter. I'll reset that. I'll make a directional light. I'll pull back my camera. And I'll start attaching some scripts again. At least my scripts were saved, so I can just attach player mover on the medium fighter. But my rigid body is no longer there. So I'll go to Add Component, Physics, Rigid Body. I'll turn off my gravity. And on my speed, I'll set it back to 5 on my player mover. So if I hit play, I can move my ship again. I'll go to my spawner. I'll set it to my game manager. And let's just make sure, okay, there we go. I have my increment right there. So now my while loop won't crash Unity anymore. I'll hit Control S a few times and even hit save. So my new script is updated. It's not an infinite loop. It won't crash my Unity anymore. I have this new spawner here. I'll take my medium fighter and I'll find the values, the boundaries of my playing field. So we got a new maximum of 14 in the Y direction. A new minimum of minus 12. So min Y will be minus 12. Maximum will be 14. I'll set Y back to 0. And let's figure out how far. So it looks like 19 for my position X. I'll go to my game manager. Position X will be, I think I said 15. I'll drag and drop Asteroid A. Well, I think I need to I'll just drag that Asteroid A back into my scene. I'll attach the mover script back to Asteroid A. I'll give it a speed of 10 this time. I'll update that prefab. Just drag it down there. Then I can go to my game manager and I can attach Asteroid A back to my game object Asteroid. I can say I want to spawn 10 asteroids. And now we're back where we were. Let's go ahead and save our scene here. Save scene as. And let's call this, let's navigate to my scenes folder. Let's call this chapter 04. So I won't do any more things like that. I'll make sure we're all saving. I won't set us up to fail anymore, but that's an example of how a logic error that does not show any kind of console errors here, and the lack of saving our scenes, how we can lose work here. So now that I got my scene saved, everything updated, I want to go ahead and save project as well, so I can save those prefabs. Because if Unity crashes, it won't even save changes you make to prefabs or materials or textures or anything like that. So infinite loops are really bad. Alright, so now that my code has a while loop with an asteroid count defined, an incrementer, and all the code for generating random locations and instantiating that asteroid, finally let's see what happens. Okay. Well, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 asteroids. Where are they going? And they should, there we go, they're just keeping on going. Alright, well, that's not exactly what we want to happen there. Notice how before the asteroids are filling up our screen constantly. Now we just get a wave of 10 asteroids coming right for us. Well, I'm going to introduce the time.deltaTime function on how we can get our asteroids to spawn one at a time. And we can also say, I want one asteroid to spawn every 3 seconds or every 2 seconds. Alright, so let's see what we can do with the time.deltaTime function real quickly. I'm going to go ahead and save my scene and my project. And for all intents and purposes, I'm going to open up a new scene so I can just show some examples of a timer here. Alright, so I'm going to create a new C# script. I'm going to call this timer. I'm going to drag and drop it just on the main camera here. There's my timer script right here. I'll collapse anything else. Alright, so let's see how time.deltaTime works real quickly. Basically, this is a function in Unity that tells you how many seconds have occurred since the last frame draw. And since frame rates can fluctuate, remember you can go from 30 frames a second to 45 frames a second, or if you're on a really old machine or the game's not really well made, you can even go down to 10 frames a second. So time.deltaTime is a way for Unity to keep an accurate passage of time throughout your game loop. If you base everything on how many frames are being drawn, then you're going to have fluctuations. And remember I was talking about the physics and the math equations? That's what will get you. So let's look at an example real quick. Alright, let's go ahead and make it inside of Unity here. I'm going to close MonoDevelop. I'm going to double click my timer. And let's see how we can get timers going. Alright. So the first thing I'm going to do on this timer is I'm going to make a new public float. I'm going to call this my timer variable. I'm not going to be living in start. Void update will be just fine. And we're going to say timer plus equals time.deltaTime. Alright, we'll hit Control S. And why don't we see what that gives us? We've declared a public float called timer. And every frame that passes by, we're going to update the timer's value, plus equal, to the number of seconds since the last frame draw. And what you'll see is this will give us an accurate representation, or a stopwatch, if you will, of how long the game's been running. So I'll minimize this. I'll select my main camera. You can see my timer right there. If I hit play, 101, 102, 103, 104, 105, 106. It's counting seconds for us. and it's just a timer that keeps on running. So what can you do with delta.time, and how can we get it to spawn my asteroids one at a time? Let's hit play here. Well, why don't we look here? Why don't we use a if statement inside here, and let's make like an alarm clock. Alright, why don't I make a new public variable? Let's call this alarm. If timer is ever equal to or greater than alarm, undo that formatting. If timer is ever greater than alarm, and let's just say that for all intents and purposes, we'll hit Control S. We'll go to main camera, and let's set my alarm to, I want my alarm to go off every 5 seconds. If the timer ever gets above 5 seconds, then we're going to trigger this if statement we're about to describe. We're going to reset the value of timer to 0. So think of it as you were holding a stopwatch and you were timing somebody and you wanted to stop the timer or the stopwatch every time 5 seconds went off. You would stop it, and then you would want to reset it for the next time you needed to use your stopwatch. And then we're just going to do a simple debug.log. We're going to say ring 5 seconds has gone by. We'll hit Control S, and let's see what happens now. With my alarm set to 5 seconds and my console window visible, let's hit play. We'll keep an eye on our clock here. When this hits 5, our alarm should go off. Ring, 5 seconds has gone by. This time when it hits 5, see how it resets its value? And every 5 seconds, we're getting this alarm written in our console. And this simple line of code right here can be used to control the rate in which our asteroids spawn. So much like how our alarm goes off every 5 seconds, we can replace this code with this code. Alright. The trick is going to be balancing your while statement with your if statement timer alarm. Alright, I'm not going to show us exactly how to do this. That's where the challenge of this lesson is going to lie. I will give us a few tips though. When you're bringing over your timer values here, you're going to want to declare these variables, or variables right here, the same way you would declare these. Alright. All of your if statements for your timer and alarm will be nested under your while statement, or while loop right here. Remember how I had that if statement nested under while at the beginning of the lecture? Well, the reason I showed you how to do that is because you're going to have your if timer alarm nested right under your while loop. Alright. You're going to have your timer plus time, or timer plus equals time dot delta time update also within your while loop. And you're going to have your timer reset within the while loop. Alright. If you have any questions on how to achieve this throughout the week, give it a few tries, play around with nesting this if statement inside this while loop. I've given you both the tools you need, all the lines of code you'll need for both. If you have any questions, be sure to email me, ask me questions. It's a little bit of hard logic to wrap your heads around, but if you understand if statements, you understand while loops, and with enough trial and error and enough times crash in Unity with infinite loops, so be sure to save your scenes, I'm sure you guys will be able to get this. So I'm going to want to see this as your final product. So here's the solution for this chapter. Within my game manager, you'll see that I have all the usual suspects. I'll have my spawn count, how many asteroids I wanted to spawn. I think we called it asteroid counter a second ago. All the usual suspects on your variables here. This is the prefab asteroid A that I want you to spawn when you instantiate. Here's my position X, my min -5, 5. Let's go ahead and remove this component. Here you have my timer that counts the times, and I have a spawn wait variable. Let's set this to 3. So every 3 seconds, a new asteroid is going to spawn. Let's hit play. So 3 seconds go by, there's an asteroid. 3 seconds go by, there's an asteroid. You'll notice my asteroid counter is counting up, and once it hits 4 asteroids, my timer no longer goes off, and my wave of asteroids is finished instantiating. Let's see how that works again. My timer goes off, and once it hits 3 seconds, the first asteroid will spawn. My asteroid counter increments by 1. Alright. I can even set my spawn wait time to 0.5 seconds. So we get a lot of asteroids spawning all at once. And I can fly all around them. Alright. So remember, you're going to combine that timer, if statement, and functionality to your while loop for your asteroids to get them to spawn one at a time. Good luck, and contact me if you have any questions on the chapter.